So the AEROKATS and ROVER Education Network is a NASA-funded project that uses kites. In true NASA fashion, it's an acronym within an acronym. So the kite part stands for Advancing Earth Research Observations with Kites and Terrestrial Sensors. We fly big kites. These are about 9 to 10 feet across, and we attach instruments to the kite. You can see hanging beneath the kite, that platform is called an aeropod, and we attach instruments or cameras to that platform. It hangs beneath the kite, and we can raise it into the air and see what's happening from 500 feet above the ground. We always wear gloves for safety. That string is about a 110-pound test line. So when that kite is out there, it is cranking, and you can actually get rope burns from hanging onto that kite line. So we always practice a lot of safety techniques. Just like any NASA mission, when we fly kites, we talk about our mission objectives. It's an opportunity to talk about the different roles for people on the team, what technologies will we use, what data we will collect. This is an example of one of the instruments that we fly. It's a Kestrel atmospheric data collector. We can get wind speed, temperature, humidity, and we can plot that and see what happens as the kite goes up. Is it colder or warmer when the kite is high or low? We also use a tiny GoPro style camera to take aerial photography. This is my favorite part of the project because you can get some really cool and interesting images. I can't see the chat, so Melissa, I'll have you look at that, but I wonder if anybody has a guess where this photo was taken or whereabouts. It is in Montana. Anybody hazarding a guess?
Is it the road to Ennis?
Ooh, no, that's a good guess. And this is the hard one. I realize it's actually up by Lewistown. It's kind of just outside the airport. We can't fly kites over the airport, so it's near, but not right near. And as you can see, one kite is taking a picture of us getting set to launch another kite, which is pretty cool. I shared this with the NASA people who are mostly back in the Washington, D.C. area. And they're like, oh my God, it's so straight. The road is so straight. Look at those lines of wheat. They're so straight, because everything back there is tons of trees and curvy roads. So they thought that was pretty cool. So another thing we can do is actually put 2 cameras on the instrument platform and get like a vegetation index and different interesting ways to use that aerial photography. I wanted to share a couple of student exercises with you. Even if you're not flying kites, I still think this is a really good way to get students engaged. I love the NASA Earth as Art website. If you just Google it, you'll find it. It has beautiful satellite imagery of Earth. This particular one is a coral atoll in French Polynesia. There's actually a town and an airstrip at the very bottom of that picture. And then on the west side, that's the only entrance into this lake, basically in the middle of the ocean. And the students love looking at these photos and picking out different aspects of the photo. I also have seen the aerial photography as an opportunity to bring in cultural sites and places of local significance. I had the kids see if they could recognize this site, and nobody could. But when I showed them the aerial photo, this is the Bighorn Medicine Wheel that is in northern Wyoming, just south of the Crow Reservation. So it was an opportunity for us to talk about sites that are sacred to different people and different cultures. And you can find photos like this too online. I can also propose mysteries with the aerial photography that we get from the kite. Here I had asked the kids, what can you see from the air that you probably can't see from the ground? They noticed in the lower left, we think that's somebody's trampoline. That's kind of back in their backyard over there. You can see somebody's garden. Hopefully there are not any naked sunbathers, but it's kind of fun for them to look. Here's another, a science mystery. What time of day is it? And how would you find out? What other information would you need to know in order to guess what time of day it is? And how precisely could you do that? Here's a last kite photo mystery. This is my personal favorite. Normally I'd put the dramatic pause and make you figure it out, but I'm gonna tell you this is Quake Lake in far southern Montana. It froze this winter and people were able to ice skate on the lake. So we flew the kite on the ice The kind of fuzzy areas are where people were playing hockey and scratched up all the ice. And if you look really closely in the bottom, there's actually a long, long shadow of a person holding a hockey stick. It's pretty cool. I might post that photo later just because it's so cool. There's other ways to engage with kites without flying the big ones. We make mini kites and a type of kite called Frustrationless Flyers. The mini kite is fun. NASA has actually developed a specific way to make the mini kite, which we do first, and then we do a mini kite design challenge. And the kids think about what happens if I add more tails? What if I do a different shape? What if it's a different material? We also have a really nice lesson plan on flight and aerodynamics that uses these really simple mini kites. The Frustrationless Flyers are a little bit bigger and really can bring in that art element. I can probably get you some of these if you're interested in using some in your classroom. So make sure you grab my email and we'll see if we can get you some of these Frustrationless Flyers for free. There's also land cover and classification exercises. This is another one that I can send to you. You print out a map of where you live onto graph paper and then have students color in those pixels or figure out how to code what type of land they're seeing. Then they can do some graphing and narrative about what they see. And I do apologize, I'm going pretty fast here, so I'll be able to circle back about this. There's all kinds of aspects of kites and math. We're actually working with some of our pre-service teachers to develop math lesson plans that involve kites. And then I know you can't even see this. I just wanted to show you the breadth of kites and STEAM. This is some brainstorming that we did with teachers a couple of years ago. They looked at ways that we can tie kites to art, to making and crafting, to history, to reading and writing, and to critical thinking and research and teamwork. So just all kinds of ways that you can build in kites into the curriculum. And then this, I really wanted to put a shout out to this. 2 of our undergraduate students last fall created a 75-page curriculum, taking this STEM content and really looking at it with an inclusive lens. It was used just last week at our Inclusive Community Camp, which is a camp for students of all abilities. The MSU students did an excellent job of shaping these STEM activities and kind of scaling back or forward. They have it for indoor, outdoor. It's a beautiful curriculum and it's posted for free in ScholarWorks through our university. And again, we'll share the link so you can download that if you're interested. I think I'm done with kites, and I am just going to keep cruising on to our next project so we have time for any questions.